Hello, everyone. Welcome to KubeCon. I'm Ashik, and I lead the internal cloud platform team at Cloudera. And I'm here with Sibiraja, who is a staff engineer in my team.
Hello, everyone. This is Sibi. Over to you, Ashik.
Yeah. So let me begin by. So Cloudera we are the creators of big data ecosystem powered by open source. Our open data lakehouse product, which is Cloudera Data Platform, enables portable cloud-native data analytics and helps organizations manage and analyze data of all types on private and public cloud. So we are the only true hybrid platform for data analytics and AI. So shipping an open data lakehouse is a massive effort, right? That's mostly because we are built on over 30 open source projects. We do dozens of releases a year. We support multiple data operating systems. We also integrate with multiple databases, hardware appliances, and all those. And because we have a hybrid, we also have to support both public and private cloud. So it results in hundreds and thousands of tests running across thousands of clusters in a hybrid environment for each release to certify quality. So being a part of an internal platform team, one of our major responsibilities is to enable development and release certifications for shipping the product, right? And in today's session, we are going to actually dive deep into the hybrid environments that we manage, the pain points that we had, how Kubernetes helped us solve it, and the challenges that we faced throughout our journey, right? So hybrid environments combine of both on-prem and public clouds. So on your right-hand side, you can see the state that we were in. We had a bunch of tools talking to multiple environments, some public cloud, some private cloud, multiple public cloud vendors, VMware in on-premise, bare metal on-premise Kubernetes clusters, etc. And as you can assume, this state was not intentional, right? Because we first started with Jenkins deploying some VMware VMs. When public cloud came along, we introduced Terraform because that was the go-to product at that time. And when Kubernetes came in, it bought Argo CD because it was tightly coupled with the lifecycle management of Kubernetes resources, right? So with all this, with the state that we were in, let's look at the pain points that we actually faced. So the major one was from the operational perspective, that it was managing all these multiple pipelines, multiple tools. Whenever a dev or a QE had to add something extra, trying to fit it in to all those tools. And along with that, developer and QEs, they were spending a lot of man hours switching between interfaces, trying to navigate the UIs and how the workloads, especially when you have to add something new or troubleshoot something, some failed test and etc. And because all these tools were independently interacting with all these environments, tracking all the resources that these were creating, both on-prem and public cloud, at a single place was not possible at all. And that was leading to resource wastage, both on-premise, on the public cloud, and we were not able to track anything properly, excessive cloud cost wastage, and poor capacity planning and forecasting, right? So how do we solve this? So, and we didn't just want to solve this anyway, like for the sake of it, but we also wanted to future-proof it because in the keynotes you might have seen and heard that Kubernetes is going to be everywhere, right? So we wanted to solve this the Kubernetes way so that we future-proof our cloud pipelines and for the coming this one. So before I go into the solutions that we implemented and the things that we did, let me just summarize the problem statement and the needs, right? So we focused on two verticals primarily. One was managing hybrid environments. So preferably, we wanted a single CI/CD pipeline, which would help us deploy things, and also a single interface to manage and interact with all the resources, and an ability to track all the resources in a single place. And in terms of form factors, along with, so a lot of our products were already containerized, but we still had some of the legacy things sitting in on-prem VMs and EC2 instances and everything. So we wanted something that would help us manage both the form factors, the containerized one and the non-containerized one. And that's where we started our journey, trying to, look at the different products in the CNCF landscape, which can solve things for us. And that's where the first, the CrossPlane comes into picture. So CrossPlane is a cloud-native control plane framework. It actually, helped us streamline our multi-cloud provisioning by consolidating management of public cloud resources into Kubernetes. Right? It reduced complexity for us by giving us consistent workflows across multiple public cloud vendors. So what did it mean, right? Like in this. So as you can see, using CrossPlane, we could manage all of the public cloud resources that we were creating through a single Kubernetes cluster. Right? So we didn't have to rely on or directly talk to any of the public cloud UIs, interfaces, or anything, and we could just rely everything on Kubernetes and manage them just like Kubernetes resources, right? So this solved much of it for us from the public cloud perspective, but the on-prem thing was still an open question mark, right? So we still had, to interact it just like a different resource, and that's where KubeVirt helped us. So KubeVirt is Kubernetes virtualization API and runtime. And this actually allows us to bring VMs into the Kubernetes ecosystem. It allows us to manage virtual machines just like how we manage pods, container, etc. in Kubernetes. And because it becomes native, we can also leverage things like autoscaler and all those things. And we can have services talk to virtual machines, ingresses, and everything like that. And the major advantage KubeVirt gave us was it was using KVM virtualization, so we were not losing any of the features that the conventional VMs were providing us, right? So and also because of this, we were also able to manage VMs just like any other Kubernetes resource. So if you see with CrossPlane and KubeVirt into picture, by using the single Kubernetes cluster, we were able to manage all of the resources, and that was just using the kubectl tool. So what this actually enabled us was to set a new standard, a streamlined and scalable approach, and it set a new standard for anything that we are going to onboard in the future, and also it set a direction for whatever is present today for itself to be aligned towards this. And in fact, we have actually moved most of our workloads and pipelines to this new standard, right? So you can see how Kubernetes acted as the centralizing force for us, and it provided us a unified platform to manage all the resources, irrespective of it being in a public cloud or on-premise or anything. It gave us a single interface, basically kubectl and basically Kubernetes modules, etc. To interact with any kind of the resources. And it gave us a very simple, streamlined, and scalable release certification and deployment pipelines. So although Kubernetes did all this, but it was not a very straightforward journey for us. It did come with challenges. Most of it was mostly due to some of the unique requirements that we had. So let's look at a few of the challenges that we faced. In terms of KubeVirt, in terms of onboarding KubeVirt, the first thing was, as I mentioned, the VMs were being treated as pods, right, in Kubernetes cluster by KubeVirt. But for our legacy applications, we needed the VM to have SSH access, external network connectivity, and a static IP address, right? So that was something that we didn't have when we used KubeVirt VMs. And for the same reason, we also needed DNS when we can't keep using static IP addresses, right? So we wanted a meaningful DNS also for those VMs. With respect to CrossPlane, the major challenges that we had was in terms of deploying a complex architecture. We didn't want to manage manifests or YAML files or things for each of the resources that we are deploying in a public cloud. We have very complex architecture, and we would have thousands of manifests in that case to follow. And the Kubernetes cluster which we were using for KubeVirt and the CrossPlane control as a CrossPlane control plane was on-prem. So managing a secure multi-cloud access was also another challenge, right? And disaster recovery. This was very important for us because now that we are relying on multiple. We are relying our release certifications on this cluster. In case of any disasters or events, we actually wanted to recover it without much downtime. So this is where I'm handing over the session to Sibiraja. So he'll be walking you guys through the things that we did, how we innovated, how we work around, and also we'll have a demo at the end of the session. Okay, thank you, folks.
Hello everyone. Let's look at all the challenges what we come across and the innovation we have did around to solve the problems. The first thing is the network. So providing the external connectivity is a deal breaker for us, and we need a routable IP for VMs and pods. And the default CNI that comes with the Kubernetes cluster that doesn't provide the support for additional network interface. And there is no support for adding the routable IP for the pods or VMs. And we explored the Multus, that is the extra CNI, and it has also no support for standalone deployment, and it only provides the support for VM and no support for pod networking, and it manages the IP addresses in the local host way that is specific to that particular worker nodes. So the solution around here is that we used the NM state operator that creates the bridge interface on all the kubelet hosts, and the Multus CNI will attach the secondary interface for the pods and networks to the resources. And we created the bridge interface by using that NM state operator and the whereabout CNI plugin that works on top of the Multus CNI, and that will be responsible for managing the IP address for the resources. So thus the resources were attached to the host network, and it allows that resource to be accessible from the outside of the cluster. And here is the network architecture overall, how it looks like by combining all these tools. So the next thing is about the network interface. Here is the manifest that captures all the network IP ranges and the routing information for the pods and VM, which can be associated with this network attachment definition. So when we create the VMs or a pod resource that will reference this as a network definition, then IP will be assigned from these ranges. So the next thing is about the DNS architecture. So having the stable DNS name for VM and pod is the primary requirement for us. The default Kubernetes DNS service, it comes with one challenges, and it doesn't support for a VM resource type, and it considers only the interface for the pod, and DNS names were also not much friendly. It has its own convention of that name representation, and KubeVirt recommends that Kube secondary DNS to handle the DNS names for VMs, and however it has also don't have support for pods, and there is no support for PTR records, and it has its own naming convention for the DNS name. So that was not that much expectation of our format. And the solution here is that there is a VMI controller which will watch for the VMs and create that appropriate records with the help of zone manager. There is a core DNS service which monitors for the resource creation and read loads when and there is a changes to the records. So zone files are maintained in the persistent volume, and they will be shared between the zone manager and then the core DNS. So then we further patch that Kube secondary DNS by introducing the pod controller to provide that static DNS name for pods, and it will watch for the pod creation, and it will create that appropriate record in the zone files with the help of zone manager. So let's look at the challenges what we face in the CrossPlane. So developer face significant complexity when provisioning resources such as EC2, Elastic Load Balancer, and S3 bucket in AWS account. And each resources requires its own manifest for creation. To to streamline the process, we leverage the composite resource claim that is part of the offered by CrossPlane, and developer can provision multiple resources together by eliminating the complex need of having multiple maintaining the manifest. So by writing just one Kubernetes manifest, they can deploy all together by using this manifest. So here the example we provided this manifest that creates the EC2 instance, elastic load balancer, and the security group also will be attached to that particular EC2 instance. So they just need to provide that as an input parameter, and everything, all the complexity of that resource creation and the actual resource management can be done by within the CrossPlane layer. So multi-cloud access management. When running CrossPlane on the Kubernetes cluster, it often requires access to cloud services like AWS or GCP cloud providers. So this access traditionally relies on the static user credentials, and which are challenging to rotate periodically, and it is not secure and efficient way. So the solution here we applied to address these challenges is by leveraging the IAM roles with a web federated identities by using the OpenID Connect. So this approach provides as the robust and secure dynamic method for enabling the access from CrossPlane to the cloud providers. So there will be a short-term credentials offered from the OpenID Connect for the service account request, and that will be used for the access between the CrossPlane and the cloud provider. So this eliminates reliance on the static credentials management and rotating, and which improves the security for the access management. So the CrossPlane disaster recovery, one critical challenge when running CrossPlane is ensuring that resilience in case of unexpected cluster failures. So recreating the cluster environment is time consuming, the error prone, and can lead to more downtime. So to address this challenge, we utilize Veliro, an open source tool to design and backup and restore the Kubernetes object resource. So it provides that option to backup that resource periodically, where we can get the data of Kubernetes resources in point of time, and then that can be stored in AWS object storage like S3. And during the restore functionality, when there is a crash happens, we can deploy a new cluster as a fresh cluster from the backup where we have to recover from the latest backup. We can use that and restore directly to the cluster, and the operation can be continued from where that left out. So this is how that Veliro helps us to set up more resilient system and reducing the risk associated with unexpected cluster failures. So let's look at the demo. So it's a recorded demo. So here is the manifest to deploy the EC2 instance by using the CrossPlane on AWS. So here we define that instance type, and then the region and the AMI ID, and these are all the tags has to be attached to that EC2 instance. So let's apply this manifest. The manifest has been applied, and there will be the CrossPlane controller in the backend. So that will try to create the resource in AWS by using this manifest. Oh, sorry. So I can't able to pause. Yeah, the instance is currently in the pending state, and let's get the instance state, and there will be ready column that denotes that the instance is deployed and state is also running. So this confirms that the instance is created in AWS, and let us run the AWS CLI to confirm the instance state. It is also confirmed that the instance is created with this public IP and state also in running. So from here we can take it forward of accessing the EC2 instance by using this IP, public IP. So next we will deploy the S3 bucket by using this manifest. It includes all the parameters required for deploying the S3 bucket, like versioning, everything. So the manifest is applied. So let's run get bucket. So this will confirm the bucket state. So S3 controller will create that S3 bucket in AWS. So once the bucket creation is completed, succeeded, the ready will be turned to true. And let's run that AWS S3 CLI to confirm what is the state of the bucket in AWS side. So this confirms that bucket is created, and this is the time of the bucket creation. So the next manifest shows that how we can deploy the EC2 instance and the S3 bucket together by using that composite resource claim. So let's apply this manifest. So basically this creates the EC2 instance and then S3. So let's run that get bucket and the instance both together. So S3 bucket is created and the instance also is created. That is the instance ID, and that is also turned to state running. So AWS S3 CLI confirmed that bucket is also created along with this. And let us describe that instance state. Yeah, instance also turned to be running now. This is a public IP associated that to instance. So this is the example of how we can use the CrossPlane to deploy or basically manage the AWS or other public cloud environment by using the Kubernetes. And let us look at how we can deploy the KubeVirt VM by using the same Kubernetes cluster. The VM is deployed, and it is scheduled on this worker 2, and the external IP is assigned to that VM, and we can reach that VM by using the static hostname or IP from our machine. Yeah. So that's it for the demo. So we would like to thank all of our open source tools, so which help us to come across all our challenges along the way. So these are our key pillars which helped us to build this project. Yeah, we are open for questions. The mic.
So mic.
First of all, thanks, Ashik. This is a wonderful presentation.
Thank you.
I'm Gaurav from BlackRock. I lead cloud team in India. So my question is that I want to get your thoughts on comparing Terraform versus CrossPlane. Because in Terraform, normally you have plan and apply phase, so more control. If plan fails, apply will not work. Or you can control when you want to apply. But in CrossPlane, as soon as you submit your configuration, the resource will be created. So did you guys think about this case? Like how do you agree that developer will create always the good things on infrastructure side of things? So how do you feel about this limitation in CrossPlane, and what's your thought about it?
Yeah. I think that is a very big limitation of CrossPlane, and trying to implement CrossPlane as a production level thing, right? I think that is still being worked upon from CrossPlane side, and we are also trying to see how we can solve that. But for us, it worked because we are mostly looking at release certification and development pipelines. Right. For that, it didn't make, this was not a big of a hindrance. But I think that is one of the reasons why this is not being as widely this one. But for us, in our use case, it sit well because we got everything managed through the single kubectl Kubernetes cluster, right? And all the tracking and everything became easy for us. We do have Terraform and everything, right? And that limitation is there. And if we were going, considering CrossPlane as a part of our production whole environment, then this definitely would have been an entrance. But it did work for our use case.
Yeah, and absolutely. I mean, if you're creating networks and virtual machines on cloud, it's a big decision to make, right? Also, is there any dry run feature, like something like a plan?
Yes, that is also something that is not there in CrossPlane, right?
Okay.
Like Terraform. So and those are the biggest hindrances, as I said, right? While looking for production thing. But for release pipelines, and because we could audit it from the Kubernetes itself, it actually made sense for us to include in our pipelines.
Okay, thank you.
Yeah, thanks, man. You can go ahead. I'll repeat the question.
You briefly touched upon the KubeVirt, and in the demo you were deploying a single instance. So how you are managing HCI in the VMs, and how you are deploying the VM workloads?
Okay, so the demo just covered the same. So your question was how do we cover multiple replica sets and all those things, right? And HA and stuff. So basically, the one that we covered is just for a single instance for the demo purpose. But KubeVirt also provides us virtual machine replica set, right? And that will just act as a replica set, like pod replica set. So you can define the number of replicas. You can have the probes and everything, and you can also have a service forward to this replica set and things like that. So KubeVirt gives us all those capabilities. No, so this is basically not mostly for the production kind of rollout. This is for release certification pipelines, right? So we don't have a blue-green kind of thing. We just want the pipeline to come up, deploy the VMs, tests to run, and just go off. Yeah. Thanks.
So how do you deploy .NET applications, and does it support .NET applications and stateful applications?
Yeah, with stateful applications, what we did was the KubeVirt, right, allows us to give persistent volumes as root volumes and also secondary volumes to the VMs.
Talking about session IDs on the client side.
So so we don't have that kind of a requirement as such in this, because as we are mostly solving the development and release certification pipelines, right? So mostly everything is static from the user side as of now. The test suite will have.
But let's assume that I wanted to migrate a .NET application.
Yeah, that I think we'll have to research around that. We have not.
Thanks.
Yeah. For our use case, that was not a.
That has been created by CrossPlane has been terminated by some other user. Will CrossPlane again spin up those things?
Yeah, there will be a CrossPlane controller for S3 and EC2. For each component it will be there. So it will make sure to sync that state always between the cloud and the Kubernetes cluster.
Okay.
Yeah.
So
we can
just like a pods.
Yeah,
like
we can configure the time that we need to the CrossPlane to monitor the resource in the public cloud. Like every hourly it can sync. Every 2 hourly it can sync. Like for example, CrossPlane creates an EC2 instance and someone deletes the EC2 instance. That's the question, right?
Correct.
So we can configure a time frame, for example, for CrossPlane to go and check, whether that still exists, and if it is not, it will sync.
Okay. So the duration can be like minutes to hours, or it's from
it can be customizable.
Customizable. But when you have a lot of resources, right, it is not generally advised to keep it very low.
It will
because it creates a lot of overhead on both on Kubernetes and the public cloud.
So this process is called the reconcile loop.
There is a reconciliation loop that CrossPlane has. You can configure the timings depending on how critical is the system for you.
Thank you.
Yeah.
How did you guys manage to distribute your Docker images across multiple clouds and in the private data centers as well? Do you guys have a central artifact repositories? The biggest challenge is, do you guys push it to a central one and then distribute it individually? We are trying to solve it through OCI, but still trying to get around it. How did you guys solve it?
So we used a very peculiar thing in this. It might not make sense, but I'll explain what we did,
sure, 100%.
right? So because for stateful and persistent things and all those, right? For KubeVirt especially, by default it uses something called data volumes. Okay, so when we give an image or something, it takes time for it to download. It creates a volume and downloads the data and then like the image and then brings to this one. Right. So we leveraged Longhorn in our Kubernetes cluster, which actually gives us the storage class with backing image. Okay, so each OS had a storage class, and the backing image would be the image that we need.
Right.
Right. So when a VM comes up, the root system would be a volume from this storage class.
Okay.
Okay, and it's copy on write. So we are not spending time at all to. We are not distributing it across anywhere. We are just creating a storage class in the Kubernetes cluster. Any VM coming anywhere in the worker node is a copy of this persistent volume, and Longhorn takes care of distributing it within.
Yeah, that makes sense on the AMI side of things. But in terms of Docker images, do you guys have central repositories for?
Yeah, we do have a central repository for Docker images, but for this KubeVirt use cases, we've stopped using those directly, and the VM image will refer to a storage class.
Okay, thank you so much.
Thank you.
Hey, thanks for the talk. So I work with Trivago, and we also have built a similar HCI in our data center. My question is, does your VMs have a static IP address, or when I reboot that machine, would that be changing? Because for us, we had to use a DHCP controller in Harvester, and that has a MAC to the IP address mapping. So how does that work for you guys? If I reboot the machine, does the IP change?
No. So basically, that's where we use this whereabout CNI, right? So whereabout CNI will take care of distributing the whole subnet or bunch across the cluster. So it is not host local or any kind. There is no any kind of mapping. So if live migration, I think you might be doing live migration.
Exactly. Yeah,
right?
that's the thing.
So when live migration, when the VM moves, because whereabout CNI is the one that takes care, it can float the IP anywhere, and we have a bridge and all those set up. So you can sync up with CB more after this.
Yeah, that
for
would be nice.
how we set up the network and stuff.
Sure, would love that. Thank you.
Thanks. Yeah, sure.
Okay. Hi, my name is Sudipto. Great talk, thanks. I wanted to know more about how you have deployed your CrossPlane and how do you take care of, is it active-active, active-passive, and how do you reconcile between two instances of CrossPlane? Or you have just one?
We only have one as of now.
Okay. Any thoughts on
we have one massive Kubernetes cluster.
But any thoughts on how you would make sure that your CrossPlane is deployed on two different regions and it is also resilient?
So we have a single control plane Kubernetes cluster, right? So CrossPlane is installed at one place, and it manages multiple clouds, right? So we didn't have a use case where we had to put CrossPlane at multiple places. We just had to link the public cloud account, and that would take care of the deployments there. Or are you talking about multiple Kubernetes clusters with CrossPlane?
Yeah, multiple regions, right? So let's say.
Yeah. So for us, the same CrossPlane was going to is taking care of all the regions. Actually, we don't have a replica of this control plane anywhere.
Essentially, if your CrossPlane is down, if the region is down, then your control plane is down.
Yes, correct. So that is where we use this Valero for a backup and things like that. And because this is again development and release, we didn't want to spend more money managing backups and all those. That was something that the decision that we took, that instead of spending so much and having HCI didn't make much of a sense for us. We could afford small time for development and release certification pipelines, right? So that's what. But Valero helped us reduce that downtime. So within that downtime is acceptable, looking at the cost that we would incur managing multiple Kubernetes servers across this one in public cloud.
Okay. Thank you.
What level of RPO and RTO you support?
Sorry.
The recovery point objective and recovery time objective.
Sorry, could you repeat?
So what level of RPO and RTO your disaster recovery is going to enable us, right? Is it in hours or?
No. So basically we have, so it will be, currently we have around 20 to 25 minutes because for the Kubernetes cluster to come up, right? So that is the level of this one that we have.
Oh, it's not active where you have a platform only. No.
Correct. Yeah.
Correct. Okay.
Yeah.
Sure. Sorry.
Images are backed up there, and then when you are creating the replicas, replicas, they are basically getting transformed as virtual disk. Hypervisors do support other types of tools, not just virtual disk. They can have tools like C tools and all that. So does Longhorn provide you that capability in terms of? So one thing is going and creating the volume from the storage array or using these plugins with Kubernetes, and you can go and create the volumes themselves. The other part is making the hypervisor aware of those volumes. Virtual disk, there's no problem because hypervisor can do a native conversion, like from your data volumes, it can create the virtual disks, and how many ever replicas you want, they can go ahead and create it. But when it comes to the other types of volume pools that the hypervisor will support, like ISCSI pools in terms of raw disk mappings and things like that, does Longhorn today support things like that, where it can also make the hypervisor aware of these raw volumes, so that when you want to deploy a VM, say I just give an ISO or an image backing, but I ask it to deploy it as a raw, on a raw volume backing rather than a virtual disk. So does Longhorn support that today, or do you have a use case like that?
We did try that out, right? So,
Yeah.
but the raw volume thing was it was very slow for us.
To import the image.
Importing image and stuff like that. So what was happening is our because for some of the certifications, we need pre-warmed data within the image itself. So it would be some 10-15 GB of data for the Hive and all those things. That itself was taking a lot of time for the VM to come up.
Okay.
Right? So it didn't make sense for us to. So we tried it a bit, and then initially we gave up any of such R&Ds because we realized that it didn't make much sense. So we have not spent much time there, and this came into picture, right? The backing image was very helpful for us. So
okay,
mostly because of the time and our unique use case, right? We didn't put much.
Okay. So one thing again, touching upon one thing is the base image itself, where the operating system and all this is coming on. Say, how do you scale those VMs in terms of the data volumes or the other disks, like as an example, the drives that you talk about, right? Say, I want to add additional file system space and additional volumes added to it.
Correct.
So again, the point there is you don't have to go and seed any data to the volume. It's like you present the volume, then the operating system takes over.
Correct.
So again, does Longhorn provide capabilities around adding those volumes?
Yes. So I think all those are the same capabilities what a persistent volume has in Kubernetes are applied to whatever volumes you are using as the root or the additional disks.
Volumes.
Yeah.
Thank you.
You want to add something?
This is Puneet from NetApp. While you run the KubeVirt on public cloud, do you enable emulation?
We use Metal instance.
We use Metal instance.
Yeah.
Okay.
Yeah, and we actually are mostly running the KubeVirt in the on-prem bare metal clusters itself.
Okay.
But we are building a feature called burst to public cloud. And whenever because with on-prem, whenever you run out of capacity, the initial to procure the hardware and set up itself there is an initial overhead, right, of time and things like that. So due to that, we are building a burst to public cloud,
okay.
and we will be adding more worker nodes in the Kubernetes clusters only. We will not be having a complete control plane or anything in public cloud. Only workers will get simulated, like spinned up there, and those will be metal instances, which will actually have KubeVirt installed and will talk to the same control plane in the panel.
Okay.
Yeah.
For the RTO, you said you have 25 minutes, right? Did you also explore any other backup solutions?
No. So Valero is what we have currently been using, and this is fairly new for us too. So we definitely will have something going forward, and I think in the next talks or something we'll present that.
Because there are other solutions which have lower RTO.
Correct. Yes.
So the main.
So major this one would be to bring up the Kubernetes cluster itself, right? So the major of the 25 minutes goes into bringing up the Kubernetes cluster in case So in case of a total failure is what is 25 minutes, right?
Okay.
In case of degradation, we are not expecting that much.
Hi, first of all, great talk, guys. What I wanted to ask, you mentioned release certification multiple times, right? So what does it mean exactly? And Could you expand on that?
Yeah, so basically release certification is, when in a functional test, non-functional QA test, and you ship out a version, a build, right? And you have to run all functional tests, performance test, and non-functional test, and all those things, right? On that thing is what I refer to as release certification. Basically, once you start building, once a developer commits a code, you have a build ready. You have to certify whether there are any things like so. All that process is what I meant by release certification.
Okay, so basically, you build your whatever Docker images, you run
your
tests.
So once you build the product, you deploy it, and because we are hybrid, you have to deploy the same thing in multiple places. Okay. And there are appliances also, Echelon and all those things that we support. So multiple places we'll have to deploy this. We'll run tests against that and see the coverage and all those things.
So basically validating at multiple
Correct,
places.
validating,
Okay.
yes.
Thank you.
Thanks.
Hello. I have two questions. The first one is, which network policies your tool is supporting? Is your platform is ready to onboard multi-tenant applications?
By network policies, did you mean?
Cilium or any other?
Yeah, we don't have anything as of that like that specifically, but for policy management as such, overall, we use something called Kyverno, but that is not a network policy kind of thing, because this is all mostly internal, right? We are not exposing this anywhere, and most of the quota is managed by something called Unicorn and all those things. So we didn't have much of a use case in that direction.
What else do you have for the namespace isolation?
Yeah, so policies as for the namespace and everything, for access ACLs and everything, we use something called Kyverno.
Okay.
Kyverno is what we use.
Thank you.
Basically to protect all the namespaces that, like the scheduler namespace and all those things, that we have Kyverno.
Hello. So I have basically two questions. The first one is, as we are deploying the thing using KubeVirt as a pod. Basically, we are deploying a VM as a pod, right?
Okay.
So what is the flexibility about the choosing the operating system? Like in traditional KubeVirt, we use some ISO, something like that, or here are we using like the base Docker image as a operating system, or something else, or some more flexibility we have?
Yeah, we do have flexibilities, right? We can use QCOW images. We can use Docker images, but what we do is we'll try to create a storage class out of it, right? Longhorn supports creating storage class using images. So
okay,
we
so something like similar like AMI kind of concept,
yes,
like
exactly.
a ready-made image that will spin up.
Correct. Yeah.
Okay. And second thing is, like, is there anything like versioning kind of thing, like that resource versioning? Let's say I deployed one VM with some stage of resource, and maybe after sometimes I updated it, maybe I updated some RAM, but I want to just maybe roll back, or I want to see the history, some stat, similar like Terraform offers. So is there anything like this?
So it is very similar to pod, right? It is so just instead of pod, it will become kind virtual machine. So it is all as flexible as how you manage
not about
pod.
flexibility. I'm asking about the historical data or the versioning kind of thing. Let's say I want to revert the changes.
So you will have to have the manifest somewhere,
manifest,
right? So
okay.
yeah, so that it is again
means the tools is not providing some historical.
no,
thing
there is no rollback as
rollback
such.
kind of thing.
But we do to support the replica set, right? We have for virtual machines, we have virtual machine replica set.
Okay.
So using that, you can roll back and roll out, yeah.
Okay, and one more small question, like during the deployment, does it provide support to the OS level? Something like, let's say, some startup script we can configure, like while running,
VNC,
that will run.
right? VNC, right?
No, the cloud init script.
Cloud init kind of
init, yeah, it does support. Yeah.
Thank you.
Yeah.
Yeah. Thank you, everyone.
Thank you, guys.